Hello, everyone, and today we'll be talking about Introduction to Psychology modules 62 and 63, which is going to talk about the dynamics of intelligence and the genetic influence and environmental influences on intelligence. So let's go ahead and let's get started. So how stable are intelligence scores? What happens to intelligence as we age? Do we experience a gradual decline? Do we remain constant? This is something that psychologists have wanted to know for years. Years is what happens as we age? We know intelligence does appear to have an increase as we get older. We do know that intelligence we seem to learn as we age, or as we get older up to a point, it seems. So what happens to that information as we get older, as we get towards the ends of our lives? Does it just go away? Do we experience a gradual decline, an immediate decline? Do we remain constant? What happens? Initially, this question was studied with what is known as a cross-sectional study. And this is a study that compares people of various ages at one point in time. So you'd compare a group of, say, 70-year-olds to a group of 30-year-olds, but you're doing it in the same year. So you're basically just looking through the age gap, looking to see, okay, this is the difference between a 70-year-old and a 30-year-old at this point in time. So in these cross-sectional studies, it was found that older adults gave consistently fewer correct answers compared to young adults. And this led to the conclusion that mental ability declines with age. The main researcher to this was David Wechsler, and he concluded that decline of mental ability with age is part of the general aging process of the organism as a whole. For a long time, this dismal view of intelligence went unchallenged. Many corporations established mandatory retirement policies, assuming corporations would benefit from replacing aging workers with younger, presumably more capable employees. Now, once intelligence tests began being distributed to entering students, several psychologists saw the chance to produce longitudinal studies, or studies with the same group over a long period of time. These types of longitudinal studies, all share the same cohort. And cohort is just the group of people from a given time period in which that study is focusing on. This can be a group of 10 people, it can be a group of 50 people, it can be a group of 100 people or more. But it's people that they follow, that study follows for as long as that study is looking at. For as long as that longitudinal study is looking at. Now, they found a surprising conclusion by giving them the same test. They retested them over a period of years. What they found was that up until later in life, about age 85 or so, intelligence remains stable, and on some tests it even increased. Now, the reason for this difference that they concluded was that they were not only testing two different age groups, they were testing two different eras of people. With this research, the myth that intelligence declines with age was put to rest. And it was confirmed that given good health, you're never too old to learn, and provided a much more optimistic view on aging and our intelligence. Now, here's a question. You have cross-sectional studies who say that intelligence declines as we get older. You have longitudinal studies that say intelligence does not decline as we get older, and in fact, in some cases, even increases. Which one do you believe? Which one do you believe is true? Which one is right? Which one should we pay attention to going forward? Longitudinal studies, in and of themselves, have their own potential pitfalls. Those who survive to the end of a longitudinal study, for example, may be bright, healthy people whose intelligence is less likely to decline. And perhaps those people who died younger or who were removed from the study had declining intelligence. So there's a question of which one we should follow. And this is further complicated by the fact that intelligence, as we discussed last week, isn't just one trait. It's multiple distinct abilities. So how do we test that? What we have found is that, truthfully, the intelligence of a person, whether they are older or younger, depends upon what's being assessed. It absolutely just depends on what's being assessed. So, on speed-based thinking tasks, older adults are at a disadvantage. Because of slower neural processing, meeting old friends on the street, names will rise like a bubble in molasses. It will be very slow for them to actually pull up that, oh, that's Janice, or oh, that's David. It'll be a little bit more difficult for them to pull up these types of things. Now, on wisdom tests, on tests that benefit from a wide breadth of knowledge, older adults tend to succeed better than younger adults. For example, a study was done in which players were given 15 minutes to complete a New York Times crossword puzzle. The highest average performance was achieved by adults in their 50s, their 60s, and their 70s. These wisdom tests assessing expert knowledge about life in general and good judgment and advice about how to conduct oneself in complex, unknown circumstances suggests that older adults tend to hold their own on these types of intelligence tests, and has given us the ability to talk about two different types of knowledge: crystallized intelligence and fluid intelligence. So crystallized intelligence is simply our accumulated knowledge as reflected in vocabulary and analogy tests, and this increases up to old age. This is one type of knowledge that increases. Fluid intelligence, or our ability to reason speedily and abstractly, decreases, beginning about 20s and 30s up to age 75, where it decreases more rapidly. Now, despite this loss in fluid intelligence, older adults did show a benefit. They showed an increase in things like social reasoning, such as taking multiple perspectives, appreciating knowledge limits, and offering helpful wisdom in times of social conflict. These older adults are more socially literate than a younger adult, generally. These can help to explain also why older adults are less likely to embrace newer technologies. All these, and explain some findings about creativity that people have had questions about. In literature and history and philosophy, people tend to produce their best works in their 40s, 50s, and beyond after accumulating more knowledge. Mathematicians and scientists, on the other hand, produce most of their most creative work during their late 20s and early 30s, where fluid intelligence is more necessity in that area. So it does help us to explain some aspects of knowledge and research that we had questions for a while. Now, when it comes to early in life, when it comes to stability over the lifespan, there is only a modest prediction on children's future aptitudes when intelligence tests are taken around ages 3 and younger. This is true of general children. This isn't true for those who are very precocious in their intelligence or who are extremely impaired in their intelligence. Now, casual observation and intelligence tests only moderately predict future aptitudes for these children. A year later, by age 4, children's performance on intelligence tests really do begin to predict their adolescent and adult scores. And this consistency only increases with the age of the child and is shown on multiple different types of tests. High scoring 11-year-olds, by the way, on the hang on one tick while I go pull up that real quick. There we go. So when intelligence tests were administered to 11-year-old Scots in 1932 and were re-administered at the age of about 77, they're more likely to be living independently and were less likely to have experienced Alzheimer's disease if they were higher scoring. These individuals were also a little more likely to live longer, although we're not sure why. There's a variety of reasons as to why they may have experienced a longer lifespan compared to lower scoring counterparts. Intelligence facilitating more education, better jobs, a healthier environment for them. Intelligence encouraging healthy living, less smoking, better diet, more exercise is another potential reason. Prenatal events or early childhood illnesses may have influenced both intelligence and health for these individuals. They may just have a well-wired body, as evidenced by faster reaction speeds, and this faster reaction speed and well-wiring may foster both intelligence and longevity. We're not sure yet why this was the case. However, these are potential reasons as to why this could be. So let's talk about the extremes of intelligence scores. So there's 2 types of extremes on the normal curve whenever we talk about intelligence. Remember, the normal curve is that curve I showed last week regarding standard deviations, how far somebody is from the average score. There's 2 extremes on the normal curve when we discuss intelligence: high intelligence scores and low intelligence scores. So, at one extreme of the normal curve is people with unusually low intelligence test scores. To be labeled as having an intellectual disability, a person must have a low intelligence score and have difficulty adapting to the normal demands of independent living. If they have a low intelligence score but are able to adapt to normal independent living, they would not be considered having an intellectual disability. Same as if they had difficulty adapting to normal demands of independent living, but had a high intelligence score. They would not be considered intellectually disabled. The intelligence test score for somebody who is considered to be intellectually disabled should be 2 standard deviations below the average. For IQ specifically, which is the one that's most often used, the average score is 100 and the standard deviation is 15. Which would place an intellectually disabled individual at about 70 or below for IQ. Now, the second part of a lack of adaptive behavior expresses itself in different areas, such as conceptual skills, and there should be some level of a deficit in each of these. They should have issues with some conceptual skills, issues with language, literacy, concepts of money, time, numbers, any of these portions. Social skills, they should difficulties with interpersonal skills, difficulties with social responsibility, the ability to follow basic rules and laws and avoid being victimized. Practical skills, daily personal care, occupational skills, travel, healthcare, things like that are required for daily living. Intellectual disability is generally a developmental condition that is apparent before age 18. Sometimes with a known physical cause, but not always. Down syndrome, for example, is a disorder caused by an extra chromosome 21 in a person's genetic makeup. One reason why people diagnosed with a mild intellectual disability may be able to live independently today compared to when the standards for who is intellectually disabled and who is not why they may be able to live more independently today is partially because of the Flynn effect. The Flynn effect being an increased score without anything really changing. Now, this is also shifting the socially accepted boundaries of who is considered intellectually disabled and who isn't. And the periodic restandardization of said intelligence tests. A person's status of being either intellectually disabled or not being so could change depending upon when they were tested, under what bounds they were tested. They may take an older test and not be considered intellectually disabled, but the moment that they take a test from 2019, 2020, they may be considered it. And it's not that the test itself changed, but the standards under which the person was being tested have. The standards at which the person is being tested against have. However, because of this today, more people have become eligible for assistance in education and Social Security, which can also help people with intellectual disabilities be able to live independently. These can come in the form of specialized education classes, both in a public school setting and in a general setting, or in Social Security payments, helping people to be able to afford living in that specific area. Yeah. So let's talk about the high extreme. Let's shift over to the high extreme, which would be, if we're going back to IQ, which would be 2 standard deviations above the average, so about 130, 30 or above. So, a 1921 study by Louis Terman studied more than 1,500 California school children with IQs over 135. Contrary to the popular notion that intellectually gifted children are frequently maladjusted and aren't very social, have difficulties with social situations, have difficulties in general along those lines, Terman's high-scoring children, like those in later studies that were repeated, were healthy, well-adjusted, and unusually successful academically compared to their peers. And by adulthood, when restudied over the next 7 decades, most people had attained some higher level of education. They were many doctors, they were lawyers, they were professors, scientists, writers, no Nobel Prize winners, but they were successful. They were successful in their careers. Now, regarding those who, whenever it comes to SAT and ACT, which those are generally some form of a test for predicting future success in college, what was interesting is that it, on some level, gave a likelihood of further success in these types of areas. People scored high on the SAT math section, the top 0.25% of their age group were the people most likely to have patents when they got older. Where at age 33, they were twice as likely to have patents compared to those in the bottom quarter of the top 1%. In this just 1% region, compared with the math aces on the SAT, those who scored high on the SAT verbal section were more likely to have become humanities professors or have written a novel in some respect. Now, is gifted education good or is gifted education bad? There's a lot of questions regarding and criticism of gifted education tracks. They say that those who are put into these types of specific education tracks may become some form of a self-fulfilling prophecy. Those implicitly labeled as ungifted may be influenced to become so. Whereas those who are considered to be gifted may also just become gifted because they were labeled that way. Denying lower ability students opportunities for enriched education can widen the achievement gap between ability groups and increase their social isolation from one another. So this is especially the case. It's important to keep in mind that minority and low-income youth are more often placed in lower academic groups, and this can promote segregation and prejudice for these groups. Now, critics and proponents of gifted education do agree on something: that children have different gifts, whether in math, verbal reasoning, art, social leadership. Every child has a gift. Every child has something that they succeed at best. Educating children as if they were all alike is a naive process. It assumes giftedness is something like blue eyes. You either have it or you don't. And that a lot of people are actually pushing back against these gifted, ungifted labels. So it's kind of interesting to see how that will develop over the next few years as people really do get into discussions of gifted versus ungifted in educational settings. Let's talk about genetics and intelligence, because this is something that's kind of interesting. So, intelligence runs in families, but is it inherited? Do the same people who share the same genes also share the same mental abilities? Research has actually shown us that this answer is a clear yes. The intelligence scores of identical twins that are raised together in the same building in the same home, are virtually similar to that of the same person taking the test twice. Now, estimates of the heritability of intelligence, or the proportion of variation amongst individuals that we can attribute to genes, and this heritability of a trait may vary, of course, but the proportion of variation of intelligence ranges from about 50 to 80%. Identical twins also exhibit substantial similarity in specific talents like music, math, sports. They will be very similar in ability when it comes to this. Brain scans also reveal that identical twins' brains are built and function similarly. They have similar amounts of gray and white matter volume, and their brains are virtually the same in areas associated with verbal and spatial intelligence, and show similar activity when doing simple tasks mentally. Are there genes for genius? Not exactly. Scientists have identified different chromosomal regions important to intelligence, but there's not one gene that you can flip and suddenly be incredibly smart, and suddenly be the Albert Einstein of your group of friends. Now, there is, however, some specific genes that have been pinpointed that seemingly influence variations in intelligence and learning disorders, but intelligence seems to be a characteristic that is polygenetic, as it is put, that involves many genes, with each gene accounting for less than 1% of intelligence variations. Intelligence is like height. 54 specific gene variations together have accounted for 5% of individual differences in height. 5%, that's it. The other 95% is dependent upon other factors besides genetics. Same thing with intelligence. There is less than 1% of your intelligence there is a little bit less than 1% of your intelligence, that is influenced by your genes. Now, other evidence points to effects in the environment. Twin studies have shown us that environmental differences do contribute to IQ score variation. When environments vary wildly, as they do amongst children of less educated parents, environmental differences are much more predictive of intelligence scores. Now, researchers have compared intelligence scores of adopted children with those of their adoptive siblings, their biological parents, and their adoptive parents. In this, during childhood, it's actually been found that intelligence scores of adoptive siblings compare modestly. Over time, these adopted children accumulate experience in their different adoptive families. And in this, it was actually found that mental similarities between adoptive children and their adoptive families wane with age, until the correlation approaches zero by adulthood. Now, genetic influence, not environmental ones, becomes more apparent as we accumulate life experience. Identical twin similarities, for example, generally continue or increase until their 80s. The heritability of general intelligence is said by Ian Deary and his colleague in 2009 to have increased from about 30% in early childhood to well over 50% in adulthood. So while we do have some ideas of this type of influence genetically, we still have many questions because we don't have answers as to what genes have influence and why genes have influence. But we do know that there is a genetic component with intelligence, even if it is small, even if it is like height, where it does play less than 5% of a role. We've found evidence that it seems to affect us more greatly as we age. Now, life experiences do matter. Just because it's seeming to only matter for a small period of time, life experience does matter. This is especially apparent in early environmental influences, and this is nowhere near as apparent as the experiences by J. McVicker Hunt, a psychologist. He went in and observed infants in an destitute Iranian orphanage. Sorry, I misspoke on the PowerPoint. He found infants at age 2 that could not sit unassisted or walk at age 4. The children there did not receive care regardless of crying, cooing, or any other behaviors that they could control. They felt like they had little sense of personal control over their environment. They were instead becoming passive lumps, for lack of a better term. And the extreme deprivation they were having were bludgeoning what would be a native intelligence. And this was the repeated finding in multiple different orphanages. So Hunt began a program of tutored human enrichment. He trained caregivers to play language fostering games with a group of 11 infants. First, they were imitating the babbling of a baby. Then they would engage in some level of vocal follow the leader, ah, ah, ah type of a deal, just kind of practicing the steps of conversing, of going back and forth. Then they would teach sounds from the Persian alphabet. Remember, this is set in the Iranian orphanage. By almost 2 years old, the infants could name more than 50 objects and body parts. They were much more receptive, much more responsive. Now, Hunt's findings show just how much environment can affect our flourishing. Among those economically impoverished, environmental conditions can depress cognitive development. Now, do studies of such early interventions indicate that providing an enriched environment gives a child a superior intellect? Most experts are doubtful in this respect. Although malnutrition, deprivation, and social isolation can hold back normal brain development, there's no real environmental recipe for fast forwarding a normal infant into a genius, for example. Later in all children, before we hop off of this, all children should be exposed to some level of sight, sound, and speech for their development. Now, later on in childhood, schooling is one intervention that heavily helps children. Schooling and intelligence both interact, and both of them enhance later outcomes. Generally, though, aptitude benefits dissipate over time. But it does provide short-term benefits for schooling. But whenever it comes down to it, genes and experience together weave the intelligence fabric. But belief and motivation do affect the outcome too. Study motivation and study skills rival previous grades and aptitudes as predictors for intelligence. And of course, if we go into thinking as intelligence as a fixed mindset, we won't ever see improvement. We won't see much improvement, if any. We'll see more improvement with a growth mindset instead. Believing intelligence is changeable, it results on a focus of learning and growing and can help us to flourish more than we would have ever if we had stuck with that fixed mindset. But with that is all I have for you this week. If you have any questions about the material that we've just covered, please feel free to send me an email or a text, and I'd be happy to answer any questions you have. And with that, I will see you all next week. Have a good rest of your day.